Hey Carsten, have you heard about the new DeepSeek-V2 language model? It seems to be making waves in the AI community.
Yes, I've been reading about it. DeepSeek-V2 is a mixture of experts' language model that boasts an impressive 236 billion parameters in total, with 21 billion activated for each token. What's really cool is that it supports a context length of 128,000 tokens.
That's incredible. I heard they used some innovative architectures like multi-head latent attention and DeepSeek-Mo. Can you explain how those work?
Sure thing. Multi-head latent attention, or MLA, helps make inference more efficient by compressing the key-value cache into a latent vector. This significantly reduces the amount of memory needed during inference.
Interesting. And what about DeepSeek-Mo?
DeepSeek-Mo enables training strong models at a more economical cost through sparse computation. By using this architecture, DeepSeek-V2 was able to save 42.5% on training costs compared to their previous model, DeepSeek-67B2.
Wow, that's a huge saving. I also read that they reduced the key value cache by 93.3% and boosted the maximum generation throughput by 5.76 times. Pretty impressive stuff.
Definitely. They pre-trained DeepSeek-V2 on a massive corpus of 8.1 trillion tokens, covering a wide range of high-quality sources, and then they took it a step further, with supervised fine-tuning and reinforcement, learning to really unlock its potential.
And how did it perform in evaluations? I'm curious to see how it stacks up against other models.
Even with just 21 billion activated parameters, DeepSeek-V2 and its chat versions achieved top-tier performance among open-source models. It outperformed models like Llama, Mistral, and Q&A 0.5 on a variety of benchmarks.
That's really exciting to see. It sounds like DeepSeek-V2 is pushing the boundaries of what's possible with language models, while also making them more efficient and accessible.
Absolutely. The team at DeepSeek AI has done an incredible job with this model. I can't wait to see what other applications and use cases emerge as more people get their hands on it.
Same here. It's always inspiring to see breakthroughs like this in the field of AI. Thanks for breaking it down for me, Carsten.
My pleasure, Sigurd. Let's keep an eye on DeepSeek-V2 and see how it continues to evolve and impact the world of natural language processing.
All right, Carsten, let's switch gears and talk about this intriguing paper on AlphaMath, Almost Zero. They claim to achieve process supervision without process. What does that even mean?
Well, Sigurd, it's quite fascinating. The researchers propose an approach that eliminates the need for manual annotation of solution steps by leveraging the Monte Carlo tree search, Mixer's framework. This framework automatically generates both the process supervision and evaluation signals.
Hold on. So you're saying they can train their model without manually annotating the intermediate steps? That's wild. How do they pull that off?
The key is that they start with a well-trained language model. With this strong foundation, they only need the mathematical questions and their final answers to generate the training data. The actual step-by-step solutions aren't required.
Okay, I think I'm following. And then they train a step-level value model to improve the language model's inference process in mathematical domains, right?
Exactly. Their experiments show that using automatically generated solutions by language models enhanced with Métis significantly improves the model's proficiency in handling complex mathematical reasoning tasks.
That's really impressive. Can you give me a quick overview of their iterative training approach?
Sure thing. They iterate through 3 stages. First, they collect a mathematical dataset with question-answer pairs. Then they employ max on the policy and value models to generate correct and incorrect solution paths, along with estimated values for nodes along those paths. Finally, they optimize and update the policy and value models using the data obtained from the second stage.
And they do this all without any human annotated solution steps? That's pretty remarkable. How does their approach compare to other models in terms of performance?
Great question. They compare their approach with strong proprietary and open source models like ChatGPT for Llama and Lemma. They also compare against supervised fine-tuning models that use high-quality seed data annotated by GPT-4 or humans.
And what did they find?
Even without relying on high-quality human or GPT-4 annotated solutions, their approach is competitive with, or even surpasses, the state-of-the-art 7B parameter models. It's a really promising direction for training models to perform complex mathematical reasoning.
Wow, that's a big deal. It sounds like their approach could make it much easier and more cost-effective to train models for this type of task.
Absolutely. By leveraging the power of MECTs and starting with a strong pre-trained model, they've shown that you can achieve impressive results without the need for expensive and time-consuming manual annotation. It's an exciting development in the field of mathematical reasoning for language models.
Thanks for breaking it down, Carsten. I always enjoy our chats about the latest and greatest in AI research.